Welcome to course on torsion of shaft. The subtopic of strength of material. Here tau upon r is t upon j is g theta upon L. This is the shaft z-axis and this is the torsion acting with the angle of rotation theta. Here tau is the shear stress, r is the radius or distance from the center of shaft, t is the torque, j is polar moment of inertia, g is shear modulus, theta is the angle of twist, L is the length of shaft. Now polar moment of inertia is Ix plus Iy, which is pi upon 64 d to the power 4 plus pi upon 64 d to the power 4, and which is equals to, that's 2 times pi upon 64 d to the power 4. We are talking about the polar moment of inertia, and this will be pi upon 32 d to the power 4. Now the polar section modulus, torsional strength is given by Zp, and tau upon r is t upon j. Hence tau max is t upon gr max. R is the distance from the shaft, hence tau max can also be called as t upon zp. What does this imply? That zp is j upon r max, which is the torsional strength. Now Zp is j upon r max is pi upon 16 d cube, or tau max is 16 t upon pi d cube. Now we will see the case of sphere, where the internal diameter is d and the external diameter is capital D. Then Iz for hollow cylinder is pi upon 32 capital D to the power 4 minus small d to the power 4. Okay, Now we'll see the polar modulus, polar section modulus for sphere, that is pi upon 32 d to the power 4 1 minus k to the power 4, and Zp is pi upon 16 d cube 1 minus k to the power 4, where k is small d upon capital D. Now for the compound shaft, what is compound shaft? So if the shaft has varying diameter, then it's a compound shaft. Now theta AC is TL1 upon G1 G1 plus TL2 upon G2 G2. Now for parallel connection, what does this mean? That if two shafts are situated parallelly and this is your torque T and the internal torque is T2, then here theta 1 is equals to theta 2, since this is a parallel connection. T1L upon G1 G1 is T2L upon G2 G2. Now strain energy is represented by U, that is so in the case of spring, and here 2 U is half d theta, which is same as that of spring, but the difference arises here, T square L upon Gj, which is again equal to tau square max upon 4g times volume of shaft. Clear? Now it is repeatedly asked, so it's important that you remember that strain energy in hollow to solid shaft is d square plus small d square upon capital D square, and torque that can be for hollow, and that for solid case ratio is d to the power 4 minus small d to the power 4 upon capital D to the power 4. Okay. And the effect of bending for a beam. Sigma is 32 m upon pi d cube, where sigma is the principal stress, d is the diameter of shaft, and m is the bending moment. The bending moment is like this, and the beams will bend. What is the effect of torsion? Let's see. This is our shaft. This is T. Now tau max in this case is 16T upon pi d cube. Now the combined case, combining the moment and torsion of the effect. The principal stress, which was represented by sigma, will be 16 pi d cube m plus minus under root of, let me write it here, it is m square plus t square. Okay, this will be placed here. Now the second case is maximum shear stress, tau max, for combined cases 16 pi d cube times under root of m square plus t square. This is the bending effect, and this is the torsional effect of the pin. Now the stress distribution or the power transmitted by the shaft. So here P is 2 pi nt upon 60 watt where omega is 2 pi n upon 60. So here we conclude our chapter. Hope you like this video. For the quick revision, keep practicing the questions, and all the best for your examination.